Hello guys, very welcome back. In this video we'll be continuing our summarized table. We'll get into more details. All right, so the first thing we'll start is with the divergence. Okay, all right, so divergent, the boundary is formed when there is ascending and diverging mantle convection limbs. It breaks and pulls the plate apart. Okay, so tensional force here. All right, so the features associated are, and there's a complete process. Okay, the first is domal upliftment. Because of these ascending limb, the temperature rises. The rocks here, it rises because of increase in temperature. Okay, so example is Ethiopian highlands. Second is the continental thinning and the stretching and rifting. Now since this is continued stretching occurs, the continental crust here thins, it stretches, and with rifting, East African Rift Valley forms. Right, it's a classic case of what you can say of rifting and continental thinning and stretching. Okay, and many isolated volcanoes like Mount Kenya, Mount Kilimanjaro. Apart from that, water accumulations have also, like Malawi, Nyasa, Tanganyika, Lake Albert. Okay, third is continental fracture and separation of continental blocks. After continental thinning and rifting, what happens is the continents, they separate, forming a small narrow ocean. Example, current Red Sea between Arabian Peninsula and the African plate. Okay, and there is block mountains which are formed here. After that, the final zone, the final stage is mature ocean basin. Okay, for example, the Atlantic Ocean, and in the middle there is the mid-oceanic ridge. So mid-oceanic ridge is the central and the most important and the final stage of this mature ocean basin, after which the mature ocean basin, it starts to converge, and the ocean basin starts to destruct. Okay, some of the examples of famous MORs are, the most famous example is Mid-Atlantic Ridge in Atlantic Ocean, Carlsberg Ridge in Indian Ocean, Lomonosov Ridge in Arctic Ocean, and Pacific Antarctic Ridge in Antarctic and Australia. Now, there are many islands which have come into existence because of the local crowning, because this particular, when it goes above the sea level, many island comes into picture. For example, Iceland, Mauritius, Lakshadweep of India. Okay, now they are faulted, right? There is many times transform faults are seen here. Okay, 2/3 of the lava flows along the mid-oceanic ridges. That's very important, and you must understand, since this is you can understand it's basaltic in nature. Okay, not very explosive, as I've told you. So basaltic rocks will be formed. Deep Valley along the mid-oceanic ridges, it dissects meridionally. So I'm talking of this particular thing. Okay, meridional dissection, and it runs all along. Okay, all along 2,000 to 3,000 kilometers and 2 to 3 kilometer. Yeah, it's 2 to 3 kilometer higher than the surrounding ocean basin proximate. Okay, so this area is known as Crustal Province, by the way. Okay, and it's roughly placed centrally within the ocean. Okay, so tensile forces, shallow earthquake, it's a shallow earthquake region, and non-violent volcanoes. Now the mid-oceanic ridges can again be classified, either it can be a slow spreading mid-oceanic ridge, or it can be a fast spreading mid-oceanic ridge. Mid-Atlantic ridge is a slow 2 centimeter per year, and it is rugged. Okay, The fast spreading, for example, the East Pacific rise, its speed is around 15 centimeter per year, and it's smooth, it's not rugged. Okay, so that was all about the divergent boundary. Next we move to something known as the convergence, right? We'll converge our plate boundary, we'll converge the basin, the ocean basin, mature ocean basin was formed, we'll converge that with an with a continent. Okay, so we'll converge it with a continent. After some time we'll hit two oceans, then we'll hit ocean with a continent, finally we'll hit continent with a continent. Okay, so let's start with ocean and oceans. Okay, so when oceanic plates coincides with other oceanic plates, right? Now if you see, these are the same kind of plates, right? But similarly, in continent, the plates are also similar. But in continent, one of the continent doesn't subduct. Okay, there is underthrusting in continents, but in oceanic convergence, one of the oceanic plates subducts. There is no underthrusting. Okay. Formation of melange, the forces are the mantle drag, it's a compressive force, right? Apart from that, this particular part of the oceanic plate which subduct, it also has its weight which is pulling off. Okay, and more often disintegration because of its own weight. Okay, known as Benioff zone, right? Now if we see this particular arc, right, the trench arc distance depends upon what is the angle of subduction. If the angle is very high, the trench arc distance would be very low, because then you know, the arc would be formed somewhere here. Okay, if the trench arc if the subduction angle is very low, right, so the arc the magmatic arc would form somewhere here, and the trench arc distance would increase. Okay, so this melange is also faulted, right? So fault in melange, trench, you know, thrust faulted, accretionary press, subducting plate. Now since this is an arc, okay, this part is known as fork arc, and this part to the continent side is known as the bark arc. We'll talk about this again. Okay, now some of the beautiful examples are New Zealand and Tonga, Melanesia, Indonesia, Philippines, Formosa and West Japan. Formosa is Taiwan. Marianas and East Japan, Kuril in Kamchatka, Aleutian in Alaska, Central America, Western Antarctica, West Indies, Virgin Islands, Caribbean, right? Caribbean islands, from Virgin Islands to Trinidad and Tobago, complete forming an arc towards the continental side. We'll talk about this. Now let's discuss some of the features of the island arcs. Now if you'll see the island arcs, the reason why they are named arcs, because they are arc shaped. Okay, roughly 1000 kilometers in length, 200 to 300 kilometers in width. They are invariably concave towards the nearest continent, and right, if here, assume here is the China and this is Japan, so Japan, it concaves towards China and it is convex towards the Pacific, and that what the sentence says. Invariably concave towards the nearest continent and convex towards the deep ocean basin. Third, it's situated at the contact of the continental crust and the oceanic crust. Okay, so here is somewhat is continental crust where it ends, and here the oceanic crust starts, and this is Japan. I'm showing this as a 2D figure. All right. The fourth feature is that the trenches are on the oceanic side here, because it subducts here, so trench naturally will be formed here, okay, on this side. And since it subducts here, you can see the andesitic lava will come here. So the andesitic volcanoes and andesitic rocks will be formed on the continental side, that is on the west side of Japan. The andesitic volcanic rocks will be found on the east side, the east coast of Japan. Basaltic volcanic lava will be found along with the accretionary melange, that is Flysch complexes, lithologic mixture. Okay, so that's very interesting, and there is a line after which there would be change in composition, and this line is known as andesitic line. Beyond that, andesitic volcanic rocks. Below this, I mean on this side, this is basaltic volcanic lava. The fifth feature is that on the western side, on the western coast of Japan, or the island arc on the continental side, it's a site of deep focus earthquake, right? Because since it's going down, and after 700 kilometers it melts off, hence it's a site of deep focus earthquake. Benioff zones explains why no deep focus earthquake beyond 700 kilometers, because it melts beyond that temperature because of geothermal gradient. And on the eastern side of Japan, or the island arc, it's a site of shallow focus earthquake, right? After colliding ocean and ocean, forming island arcs, right, and trenches, now we move to ocean and continent, right, and forming volcanic arcs over the continents. Now, after ocean and ocean collided, this ocean plate subducts. This ocean plate it starts subducting at the continent. Okay. Again, creation of huge accretionary prism called melange because of scrapping. Okay, and one of the example is that these scrapped mountains, the scrapping is higher as compared to that of ocean collision. So much so that fold mountains like Andes form, and andesitic volcanoes are also associated with it, because of the reason I have just already told. Okay, so when this subducts inside, this volcano formed in an arc, hence it's named as volcanic arc. Next will collide two continental plates. Very strong compressive force leads to huge formation of huge mountain chains which are very high, for example the Himalayas and adjoining Tibetan plateau. It is associated with no volcanoes, but there may be a remnant of early eruptions, right? The important thing is there is no subduction, it's only under thrusting taking place here. Okay, finally we move to the conservative boundary, right? Two plates sliding past one another, moving in opposite direction or moving in the same direction with a different speed, right? The thing is, they are not destruction. There is no new plate being formed. There is no plate getting destructed. Okay, the plate is getting conserved, right? The motion is along the fault, that is transcurrent or transform fault. Example, the San Andreas fault. The Juan de Fuca fault is sliding northwestward of North America. No volcanoes, but there is seismicity because the movement is restricted and there is unlocking of locks, and hence there is earthquakes. Alright, so let's summarize. We talked about convergence, we talked about divergence, and we talked about the conservation, right? Conservative plate boundaries, divergent plate boundaries, and convergent plate boundaries. So that's all. Thank you.